Hi TheCodeMans, welcome to another video. Today we are going to dive into caching. We are going to explore differences between memory caching, distributed caching, output caching, and where to use which caching. Let's go. So let's say we have some API that contacts the database and clients can contact the API through the server. In the basic flow, this client will talk to the server to contact the API to return some data from the database. Database will return a response to the API, and through the server, the response will be returned to the user. The another request will be the same. If we are searching for the same data, for example, we are searching for the product with a certain ID, the flow will be exactly the same. I can show you this in a Visual Studio, just a quick example. We have just a program CS file. We introduce one class product with ID, name and price as a properties, and we have one method which will simulate getting products from a database, and for that case I will just slip a thread for 2 seconds just to simulate a slow DB query. I will return response with those 3 products. In the main function we have just one minimal API map get to get all the products, which will call the get products from DB that we have created. Okay, let's run this one and let's see the results. Okay, we are in the Postman and I will call the products API endpoint. Let's send this request. You can see that I'm waiting for the response a little bit longer, which is exact 2 seconds, for which we stop the thread. If I go and hit send again, it will be completely the same, more than 2 seconds to return the data. The problem here is that every request hits the database, which causing unnecessary delays. And this is where caching comes into play. So how we can improve this call? We can introduce a memory caching. Memory cache stores the data in server memory, and this is the reason why it's usually really fast. Most of the time, this memory is RAM memory. How does this work? Before the database is called, we will check whether the data we are looking for exists in a memory cache. If the data does not exist, we will call the database, return the data from the database, and after that we will put that data in memory cache so that next time we can retrieve it from the cache instead of calling the database again. If the data exists, the data is instantly returned as a response and the database is not called at all. So what are the benefits of memory cache? The first benefit is fast data retrieval. As we said, memory cache is stored most of the time in RAM memory, which is really fast on the server, so you have fast data retrieval. The another one is reduced database load. If there is a data in memory cache, you don't need to call database again, you will just retrieve the data from the cache. And the last one is simple to implement. We will see that in a few seconds. What about drawbacks? So the first and maybe most important drawback is that there is no persistence. When you restart the application, memory cache will be empty. Another drawback is that it's limited to single application instance. We will see in the next example why, and we will see how to solve that. Okay, let's implement this memory cache in our code. So the first thing we need to do in order to use memory cache is to add it through dependency injection, add memory cache. And let's create another endpoint. Okay, the first thing I will need here from the dependency injection is interface of iMemory cache. Let's name it cache and let's implement this one. Let's have some cache key which we will use for getting valid data that we need, and I will try to get a value from the cache with a cache key. In this case, I will call the database, get products from DB, and after that I will store value to the cache using my created key and the return data. And we can pass time span, which tells the cache how much time this cache will be valid. For example, from seconds, let's say 10 seconds. On the end, I will return directly products. So if there is data, I will return that data immediately. And if not, I will get the data from the database. I will cache that data in memory cache to be able to pull the data from the cache instantly when I call the same request another time. Okay, let's run an application and let's try to see what we are going to have right now. Yes, as we can see, the response time is 2 seconds and we have all the necessary data. And again, if I hit the send button, I expect to have those data instantly returned with a couple of milliseconds. Let's go and try that. As you can see, 43 milliseconds, 5 milliseconds, 5 milliseconds, 4 milliseconds. That's it. What happened? If I put a breakpoint here and if I go back and click send, I will try to get the data from the cache, and you can see that this part of the code is skipped, which means that this data already exists in the memory cache, so I can return it directly. So one of the drawbacks for memory caching is that limitation for single application instance. So if you have multi-environment services, for example, you have 2 or more instances of your API, when client call the API, if that calls go to this API instance, for example, instance number 2, and instance number 1, we have memory cache with some data, client will not get those data because those two separated machines have separated memory cache. So in this case, memory cache will not work. But there is a solution for that, and it's called distributed caching. Most of the time for distributed caching, Redis is used because it's the most popular and it's really fast database. So in this case, if clients call the API and it goes to API instance number 1, API will check in Redis if there is a data, and if there is no data, API will call the database and will return the data to the client. Similar to memory cache, in the next call, if the same request is sent and if that data exists in Redis, API services will not call the database. Data will return from the Redis. If that request lands to the API instance number 2, that instance has the same connection to the Redis and it can pull the data instantly to return to the client. What are the benefits of distributed caching and what are the drawbacks? The first benefit is really obvious because you can have shared across multiple instances. The another one is the persistence. So in memory cache we don't have that persistence, but since the Redis is completely separated infrastructure part of the application, this database is persisted like any other database. So even if you shut down the application, the data will still be in the Redis cache. And another important thing is that scales horizontally really good. So the Redis works really well with API gateways. What are the drawbacks? So the first one is the network latency. Why? Because API and the Redis cache communicate via network, and here there is a latency. Another one is a higher cost, of course, and the third one is, as I said, you need additional infrastructure. For example, in this case you will need Redis or some other database, never mind. Okay, because of good combination between memory and distributed caching, we can use both in the same application in the same request. So this would be some flow. For example, if client calls the API, the first thing, for example, this instance API number 1, let's call it, is to check in local memory cache. So if there is a data in local memory cache, that is a really fast response that API can return to the client. If not, the API will call distributed caching. We'll try to get the data from the Redis. If there is no data from the Redis, the API will call the database and will return the data directly from the database. But it will update memory cache, and in the same way it will push the data in the Redis cache. Okay, I will not separate those two. I will show you how to implement combination of memory and distributed caching with the API that we currently have. Okay, let's go to the Visual Studio. The first thing I need to add is support for the Redis. Add stack exchange Redis cache. Currently I don't have this method available because we didn't add NuGet package. Let's search for Redis and I will install this NuGet Microsoft extensions caching stack exchange Redis. Now I can see there is a method that I wanted, and for the options I can set a configuration which will be local host, and the usual port for Redis is 6.3 79. I have already installed Redis cache through Docker, so I will run my Docker desktop. You can see that I have local Redis. You can start by simply clicking start Redis. For the code, so with memory cache, I will add distributed cache also. I will create a list of the products. So we can see here that first thing we are calling is the memory cache, and we are trying to get the data from the memory cache. Another thing is to call Redis, so let's implement in that way. I will try to get a value from the memory cache, and if there is no data in memory cache, I will try to do the same thing with Redis. Let's track this execution through writing to console. So here we know that there is no data in memory cache. Let's check Redis cache. So let's say Redis data. We can call Redis cache get string async cache key. Why we are trying to get string? Because this is a JSON result. We will serialize this list into string. If Redis data is not null, that means that we are returning data from the Redis. We found data in Redis, so we need to push it to the memory cache. The first thing I'm going to do is to use JSON serializer to try to deserialize this list we have of the product, which is in Redis data. And now I can set memory cache with a cache key. I can set products time span from minutes, let's say 10 minutes. So this is the case where there is a data in Redis. We will deserialize data and we will put the data to the memory cache. If there is no data in memory cache and if there is no data in Redis cache, I need to get data from the database. So we have products, get products from DB, and here I can say that I'm pulling data from DB. The another thing I need to do is to store those products in Redis cache and in the memory cache. So for the Redis cache, we have wait Redis cache set string async, and we need to serialize that. Here I can pass also time span for expiration. We store the data to Redis cache, and now we need to store data to the memory cache. Set cache key products and time span from 10 minutes. Okay, let's start the application. So this is the first call of the API endpoint. What will happen? Let's see. Okay, we got the data from the database. What happened? I tried to get the data from the memory cache. Okay, I got a red line. I tried to get data from the Redis cache. Okay, I got red line, which is I didn't get the data because there is no data in Redis and memory cache. And as a last step, I will get data from the database. Since we got the data from the database, we push that data to the memory cache and to the Redis cache. So the next call will check first the memory cache and will return the data from the memory cache because we already put the data in the memory cache. Let's see. So as you can see, data from memory cache, and this will be the every next call because data is persisting in memory cache for the next 10 minutes. Okay, let's for example shut down the application and let's try again. As you can see, the last call was from the memory cache, 4 milliseconds. I will try again. Okay, now we have data from Redis. Why? Because we shut down the application. The memory cache does not exist anymore currently. The next step is to call Redis to try to get data from distributed cache. So you can see that we have some new response time, which is 700 milliseconds, and that is the network latency to call Redis cache. If I try to send again, I'm expected to get data from the memory cache. Why? Because when we got the data from the Redis cache, we push that data to the memory cache. So this approach with combination of memory cache and distributed cache are pretty common thing in software engineering, especially in microservices. So let's continue with another type of cache. So is it possible to cache a response without calling memory cache, without calling Redis cache, and without calling even database? Yes, it's possible. From .NET 7, there is something which is called output cache. Output cache is for high performance API responses. It's stored in a server memory, and caching the entire HTTP response on the server before processing reaches middleware. In that case, if we cached API endpoint or even a Razor view, MVC view, or HTML page, there is no need to go further in processing request. The complete HTTP request will be returned to the client. So what are the good sides and what are the bad sides of the output cache? The first one is that drastically improves the response time because the complete HTTP request is returned to the client. There is no need for any processing on the server. The another one is really easy to implement. You will see it's just a pure configuration in program CS. And the last one is that works really well with client and server-side caching. It can be combined with browser caching using cache control headers. The better sides of the response caching is that may serve stale data. You can maybe see some stale data from the past request. The another one is that it is limited to HTTP responses, which means that complete HTTP response is cached. It's not just a data, and it's not suitable for the user specific content. For example, if you have some user dashboard, this will not be a good solution without proper caching validation. Okay, how to implement this? As I said, it's really simple. So let's go back to the Visual Studio. The first thing, you assume that we need to add a service for output caching, and we need to use a middleware app use output cache. And for this one, on the minimal API, I will just add another method which is called cache output with some parameters, and that parameter can be expired. Okay, let's try this one. So now we have a clean solution without memory caching and without distributed caching. We just have output caching. So the first request to the API will last for more than 2 seconds, like for the first time. And if I click it again, you can see that now the response time is 13 seconds. We are returning a complete response. What is interesting that you can see here, so you have age, and age show us how many seconds that data is old. If I go and run it again, you will see age will be 18, 21 seconds, 23 seconds, 24, 25, etc. until 1 minute. After 1 minute, the response time will be again 2 seconds without age header. If I go run it again, you will see age 6 seconds. In order to better understand this, I will do something like this, and I will put breakpoint here inside of the endpoint. Let's see what's happening. The first call of the endpoint will land on that breakpoint because it's entered in endpoint request pipeline. If I try to do that again, you will see I will not land to the breakpoint. The complete HTTP response for this endpoint is cached for the 30 seconds. So that's output caching. And the last one is response caching. So what if I don't want to call server at all? I want to allow client to define what to cache via cache control header. This is possible with response caching. So response cache caches entire HTTP response as for output cache, but uses client-side proxy or CDN caching instead of server caching. So how response caching works? Client requests a resource, for example, get products as we have. The server processes and responds with caching headers, cache control, public, and with max age, and all other requests within 60 seconds are served from the cache, most of the time from the client cache from the browser or proxy. And once expired, the client requests a fresh data from the server. Okay, let's see how to implement response cache in .NET. Okay, for the response caching, it's pretty similar as for output cache. So I will need to add it to a dependency injection, add response caching, and I need to tell the application to use the middleware, use response caching. So let's call a products, let's pass HTTP context, and for the response, let's say context response get typed headers, and let's set a cache control. For the cache control, we can set many properties. For example, is it public? True. And we can set max age to be, for example, let's say 30 seconds. This setup here will add cache control header, which is public and with a max age. We will see that in the Postman. And let's delete cache output. We are ready to run application. Let's see. Okay, we are in a Postman. Let's try to send a request for the first time. It's more than 2 seconds response time as we have by default. And you can see here we have cache control header, which is public with max age of 30 seconds. If I try to execute this once again, I will get 10 milliseconds and I will get another header, which is age. I will try again and again, and you can see that we are getting this response from the cache. And okay, what are the benefits and drawbacks for response caching? So the benefits are, the first one is improves performance and reduces load. It is a standards based caching, which means that you can control it with some particular standard headers, cache control, expires, etag, etc. Another one is that there is no server memory consumption because it's cached on the client side, and you have configurable caching rules. You can create your own rules for caching. The drawbacks are that it is not ideal for dynamic content. Another one is that no persistence across application restarts, which means that if front-end application has been restarted, you will not have that cache anymore. It relies on client and proxy behavior, which means that some clients even don't care about cache control header, so you will not have response cache. Okay, so when you take a look on output cache and response cache, you can say, okay, Stefan, those two are pretty similar. And yes, those are pretty similar, but there is a difference between them, and I will show directly in Visual Studio in the code to try to understand what are the difference between output cache and response cache. So here I added a middleware which will just write to the console on certain data about processing request, and I just created two endpoints. The first one is for output cache, and I name it product/output. For response caching, I have added another endpoint, which is product response, and for the message, I'm just returning response cache. Okay, let's start the application and let's see the difference between those two. Okay, application is up and running. The first one we are going to test is products output. I'm going to call this one, and you can see the message from the middleware, processing request. If I run again, you can see the same message, and for all of those requests, you can see the timestamp is the same, which means that server already cached this response, but server is contact to check if the output is cached. The execution will stop in that middleware and will not enter into endpoint at all. Okay, what about products response? If I go and hit enter, you can see get product response, timestamp is 9, timestamp is 9, timestamp is 9. So you have timestamp tagged, which means that this is cached, but the difference is that server is not called. As you can see, there is only one console writing in the middleware. Okay, that is the main difference between output caching and response caching. For response caching, there is no need to call the server and to get the data from the server, because response caching allows us to cache the data in browser, proxy, or CDN. For the output cache, the response is cached on the server side, but there are requests to the server to check if there is a response cached in the output cache. So those are some final thoughts where you should use which one. A memory cache is good for using for quick lookups. Redis is the perfect for multi-server environments. We have response caching for reducing redundant API requests. So if there is no need to call server for a couple of seconds or a couple of minutes, response caching is awesome thing to do. At the end, we have output caching for fast server-side responses. The important thing for those two caches, response and output caching, they don't work very well with dynamic content because both of those cache the complete responses. That's it for today. If you like this video, give it a like, subscribe for more .NET content. See you in the next video. Dream big.